The fastest way to wear out rings in an engine is 1. Overheating it, 2. Running it with no air filter or a damaged air filter, and 3. Not changing your oil. This is not a good idea because it's a lot of work to change your rings. When removing a piston, they almost always come out through the top of the engine. But on an old worn engine, you can feel a little ridge here. That's called the wear ridge. There's the original part of the cylinder which is unworn, which sits above that ring, and the worn part, which is always wider at the top and narrower on the way down. And sometimes when you're trying to get the piston out, it doesn't want to come out, and it catches on that edge. It can actually break your rings. Now there is a tool called a ridge reamer. You can mount it on your head, and it spins around and it cuts that off. That's a good idea if you have an engine with a heavy wear on it and you want to get rid of that groove and get your piston out. On a lot of the small, just cheaper ordinary lawnmower engines, you can see that the cylinder wall is made of the same material as the block, which is aluminum. It's a poor design, but what they've done to it to make it last longer is anodize it. That's a way of hardening the surface of the aluminum. It doesn't last as long as a regular engine does with a cast iron sleeve, but it improves the life a lot. If you rebore an anodized cylinder, then you're cut into the fresh aluminum. It's not anodized anymore, it's not hardened, and it won't be that long after, even though you have a new piston, new rings, and everything's done right, before that engine starts to consume a lot of oil. Another thing most people don't even notice is pistons are machine tapered. That means they're narrower at the top and wider at the bottom. The reason being is the top of the piston becomes the hottest when it's running, so it expands the most. So it has to have room to expand, so when the piston's at operating temperature, it becomes more square, less tapered like it is now when it's cold. There's different kinds of wrist pin designs. The wrist pin is this chrome pin going through the piston. It's hollow for lighter weight. This particular piston came from my Shelby Z Turbo 2 intercooled Aries. It's called the full floater type. It has little locking rings on both ends, and even on the rod, the piston pin can float on the rod. Many common engines, V8, small block Chevys and stuff, have what's not called a full floater, and the wrist pin is pressed into the center of the rod, and then just the piston moves on the wrist pin, but the wrist pin is fixed to the rod. Almost all small two-stroke engines and off-road vehicles like quads, ATVs, dirt bikes, motorcycles have the full floater type with the clip on both sides. The disadvantage of these, if it's a high revving engine, is this wrist pin moves back and forth just a little bit all the time, and it hammers on these retainer clips, and eventually they lose a bit of spring tension and they wear down a little bit, and they can actually pop out and get caught between the piston and the cylinder and destroy everything. On this two-stroke cylinder, that's what happened. Way down at the bottom you can see little indentations on the cylinder head. Well, that's where pieces of that broken clip dented the piston, dented the head, and if it wasn't so dark in here, you can see all the gouges in the cylinder wall. Unfortunately, there's no warning when this is going to happen, so this is why racers like to rebuild their two-stroke engine every year, at least with a new piston, just because they have no idea when this is going to happen and destroy their top end. This one that came from my Aries station wagon, it actually happened. It was at about 250,000 kilometers on my first engine. The clip on this side just wore. It broke into two pieces, and the pieces were caught in this pocket. They just bounced around in there for probably another 20 or 30,000 kilometers, and then, since there's no warning, I didn't know anything was wrong. Now here you can see the exposed edge of the oil scraper ring. It eroded aluminum. It wore this pocket a lot bigger, but at the same time it was wearing the cylinder wall and cutting a gentle rounded groove or score into it. Pieces of that broken clip came through the wrist pin hole, went to the other side of the cylinder, and eroded it too on the piston and wore the cylinder wall. The only way I knew this was happening was when it was too late. I opened my oil cap when the engine was running, and there was so much blow-by blowing out. The pressure was getting through the piston wall and between the cylinder because it was all worn from the ring rubbing on it. It got to the point where it was so bad that even with my oil cap on, if I accelerated harder in the car, it would blow the dipstick right out of the dipstick tube. When reinstalling pistons back in an engine, most of them have a little arrow that always points to the front of the engine. That's very important to install them in the right direction. If you don't know the history of your engine and you're changing pistons or rebuilding it, they often have a tiny number on it. Might say 0.010 or might say 0.5. If it says 0.010, that means it's 10,000ths of an inch oversized. The engine has been rebored once. If it says 0.5, that means it's 1/2 of a millimeter oversized. So it's also been rebored and had a larger piston installed. Most engines have three sizes of piston, 10 thousandths, 20 thousandths, 30 thousandths, or 0.5, 0.1, or 0.5, 1, and 1.5 millimeters oversized. On this full floater piston was on the connecting rod. In a typical lawnmower engine, some of them don't have a pressurized oil system. This one had the Slinger oil system. It just had a plastic wheel with little fan blades on it that sits in the oil, and when it's running, it's just flying around, dipping into the oil and flinging it all over the place, and hopefully oiling the engine. It's not the best system. In four-stroke engines, in cars, and all good quality engines, it's a pressurized oil system. So somewhere on the crankshaft wrist pin, there's an oil pressurized hole because there's oil pressure going through the crankshaft. This hole lines up with a hole in the crankshaft when the piston's at the right position, and then it goes squirt and it sprays a mist of oil all on the cylinder wall and inside here to lubricate it. On some diesel engines, extra lubrication up in here is much more important because of the higher compression and more forces on the piston. So they may even have little pipes that run inside the engine, in the crankcase, and little squirter tubes specifically pointed to spray in that direction and give extra oil up to the top of the piston area. When you're putting a used piston back in an engine, two-stroke or four-stroke, there's always some carbon on the top landing here between the crown of the piston and the first ring. It's a good idea not to remove that carbon. If there's carbon in the ring grooves or anywhere else in the piston, it is a good idea to remove and clean it. And a good way to do that is just take a piston ring, break it in half, and use it as a cleaning tool to scrape out that crud. Scraping the carbon off the top of the engine is called decarbonizing, and that's a good idea too. The more oil an engine burns, the more crud you'll find on your piston. Not much of that is left from gas deposits. You can see the scoring on this particular piston. The scoring has actually damaged the piston so much that it's pinched the rings into the ring grooves, and this piston lost compression in the cylinder because of that, because it lost its sealing ability. This was done because it's a two-stroke lawnmower engine and somebody forgot to mix gas and oil together. That means this piston is destroyed and the cylinder has to be rebored. On this four-stroke engine, you'll also see a bit of scoring. The scoring is at the top, and that happened because this engine had a mouse nest in it, and the top of the cylinder area got too hot, and it started to melt to the piston a little bit, and that scored it there. If you can feel the scoring with your fingernail very well, your engine's probably too damaged to want to put back together the way it is. You may have to do something about it. Whenever you're putting a different set of rings into a used cylinder that hasn't just been rebored and honed, you should run some sort of honing tool in there, or a deglazing tool. Another one's called a grape tool. It looks like a bunch of little wires with little carbon, with little abrasive balls on the end. You stick this in the hole, put it on a slow speed drill, running it at only about 100 or 150 RPM, and while it's running at that speed, you're quickly going up and down while it's spinning. Doing that makes spiral crisscross patterns on the cylinder wall. All new engines have that. That's a great idea for two reasons is, one, the little tiny scratches in the cylinder wall cause the cylinder wall to hold a little bit more oil, and that causes your engine to wear less and last longer. And two, when all the new parts are in there, it causes the engine to more quickly cause the rings to wear in and fit exactly round to that cylinder and seal better. If you run your timing too advanced, or the wrong octane of fuel in a higher performance or higher compression engine, the spark plug fires it in the middle, but it will fire and pre-detonate, called pre-detonation, before the piston gets to the top, and try to push the piston back down the wrong way when the engine's trying to push it the other way. So what often happens is a crack will form at the weakest point of the piston. So a crack will start here and go to here, and it might go all the way down to here. Very rarely does the whole piston disintegrate, But that crack causes the rings to have a little zigzag in them and bind, and then quickly that piston loses compression, and if you rev the engine very high, that piston can detonate and blow up. The reason why the piston doesn't all fall apart when it gets a crack from pre-detonation is quite well-made pistons have steel bands cast inside the aluminum like this piston does. You can see it again there. Kind of gives the piston lots of structural integrity. And there's three common methods of making pistons. One is cast piston, where the metal is just poured like hot aluminum into a mold and formed. Well, that's the poorest design. That's like this one for a lawnmower. That's in many low performance engines and